Are we live?
Yes, we're live. Hello, everyone. I'm so happy to see all of you on this virtual talk session. And today we're going to talk about Apache Kafka. And our speaker today is magnificent Viktor Gamov.
Hello,
Hey,
everybody. Yes, thank you so much. I'm so excited to be here at the virtual jug again. Still have my award from the previous time, my juggernaut for Java Puzzler. So I hope this session will be also up to the standards that we established during Java Puzzler session. So really excited, really excited. A lot of things to discuss. So
yeah,
nothing is
better than a humble bragging about your past achievements. So, but yeah, now you're gonna deliver.
Why not? Why not? Right? So we did this, and the community received this very well. Thank you, community. Thank you, guys. It's like really excited. Do we know how many people we actually have online right now?
We are not sure. More than 100 for sure. I get some information about some audio sync issues. So we are gonna check that momentarily. Let me just go on the virtual jug.
Is it me or it's in general?
Yeah, I can hear a slight delay, which is very interesting. Can you switch your mic to a different mic? I know you have tons of mics.
So what's the problem? So you cannot you can't hear me online?
No, I think there is the video and audio. They're desynchronized.
I probably can turn off the video. So in this case, if you can hear audio very well, so it would be more than enough. So let us know. Let us know if you can hear audio well.
Yep.
So I turned off my my video and
Okie doke. Yeah, I think it has fixed itself. So if you will, anyone who is watching, let me just go through some details before we start. Let me just share this thing. Wait. Yeah, if there are any issues, then we are in Slack, and you can. Hopefully, you can see my.
Thank you for.
Excellent.
Thank you, Alexander, who said photo is better. So.
Photo is better. Excellent. So can you see my screen? Hopefully you see my screen and not my presenter notes. Anyway, today we're going to talk about Kafka and Viktor, who is a solution architect at Confluent. So he has been a developer for I don't know how many years. He has tons of experience in enterprise applications and distributed systems. He organizes Princeton Jug and is a book author and organizes a Russian podcast, Razbor Polyotov. And I'm sure he has a slide about himself as a proper public person. So he will talk in more details about himself, but you should follow him on Twitter. So if you have any questions about Kafka or about Java development or JavaScript or software engineering in general.
We have this comment that we don't see any slides in the live translation, in the live session. Also, I only see my picture. I just opened YouTube application.
Fantastic. Let me show it. Excellent. Now we can see that.
Yeah.
So anyway, we are in the virtual jug Slack. There is a link under the YouTube video. There is a link on the meetup page. Just join us in the channel live session. We can talk and you can ask questions, and I will forward your questions to Viktor at an opportune moment, probably at the end of the session. You're welcome to share the group, the virtual jug, and this particular session. The more, the merrier. We are running on YouTube and Hangouts, so let's stress test that architecture. And if you have any feedback, you can reach out to us on Twitter. It's at virtualjug or at Shalife if you want to tell things to me personally. So without any further ado, with all those details about the stuff out of the question, let's.
Okay, so now we're live. Okay.
Now we're live, and this is Viktor, and he's going to talk about Apache in the session. And now back to you, Viktor, and I'm going to upload the videos and share that with everyone, so everyone who was previously watching us could join us now. So Apache Kafka, Viktor Gamov.
All right. Thank you, Alec. Guys, just look into. I don't see any the YouTube live videos right now. Okay, so I just see new one. And apparently people can see my screen right now. So I would say, Alec, you need to share a new link with the people so they will be able to join live chat. But anyway, so while you're doing this, do we need to like wait for 1 more minute people to rejoin? I see 46 people watching this right now, so I think we're kind of good, and some people were able to join.
I see 70 viewers right now, and I hope everything is fine. And I'm gonna continue redistributing this new link. So
right, yes, and under previous video, there's a chat window. In this chat window, I think you can share. Oh no, it was live chat. So no, never mind. Okay, so we're good to go.
Yes, we are.
Do we have people in Slack? You monitoring this? People will be able to see it. 72 people. Okay, I think we can start. And after that, you can do this like a magic editing. And now we're rolling. Okay, welcome to virtual jug session about Apache Kafka, a streaming data platform. And today, we're going to be talking obviously about Apache Kafka. Apache Kafka has a similarly sounding name as a famous Czech author, Franz Kafka. We're not going to be talking much about Franz Kafka, though some of the ideas about literature and how one writer can write a poem or write some text, and multiple people can read this in their own pace with their own capabilities is actually a fundamental thing how the Kafka works. So there are lots of similarities. I'll try to point it out during the session. So my name is Viktor Gamov. I work as a solutions architect here at Confluent. At Confluent, what we do is we essentially building better Kafka. No, it's not maybe the right way to say. So Apache Kafka is the open source project that was created by founders of Confluent. And in Confluent, we're providing support. We're providing some additional feature. We're contributing a lot of work into Apache Software Foundation. Though we're also building some of the tools that I will be demonstrating today that help developers to use Kafka and the complex stacks like streaming platforms more efficiently. I talking to developers and I'm trying to bring the feedback from community to product so we can give you better and better experience where you can work with these tools like streaming platforms for streaming applications, etc. So I consider myself a little bit of developer advocate. Also, I'm posting in Twitter things. You can find me in Twitter, as I like mentioned on the very beginning. You can go and follow me in Twitter. If you will have desire to tweet some slide, you can do it during the session. There always will be Twitter handler for me, for Virtual Jug, or for Confluent. You can follow these Twitters if you will be interested. If you're interested in some streaming aspects, Apache Kafka aspects, and some other materials. All right. So, as I already mentioned, at Confluent, we do all things around Kafka. And in Confluent, we believe that the streaming platform can be in the heart of every modern enterprise for data exchange, for data transmission, data transformation, etc. We're providing tools, services, materials, training, all things around Kafka and streaming platforms. Also, we're hiring. So we're hiring in multiple teams. I'm hiring in the team of professional services. So if you are looking for a place to work, I have couple. We have couple opportunities for you. So this is, it's a great opportunity to join this team. All right. So now let's talk about this data flows. So if you think about this, any organization, every company, every enterprise is built on top of idea of data flow. So information is flows between different organizations, different organizations within organizations. So you can go to talk to your colleagues, and this information is flowing from one place to another. So you exchange information constantly. Or there's some services that you building in your organization that will require some data from other services that someone else is building. So essentially, data flows is a fundamental piece of any data-driven organization. Now, but so what we actually end up doing is building data stores. So instead of exchanging this information and let this information flow without boundaries, we storing this information in some sort of data silos. And over the years, building the enterprise architecture will end up with something like this, when there's multiple interconnected links where you need to pull the data from different sources if you need for your application, and so bigger sources of this data that increases latency of the response that you need to provide to a user. Or sometimes when you're trying to figure out what's the data flows, what's the data origin, what's the data lineage, it's becoming very difficult to understand, and your life becoming as an episode of It's Always Sunny in Philadelphia, when Charlie is trying to find a Pepe de Silva to deliver um, email. Oh, not email, mail. So by introducing streaming platform, this is what we believe. This is what we're trying to demonstrate organizations. This is what we're trying to help organizations and companies to build, is to make this data flow through, we call it streaming platform. We call it streaming platform that allows applications, allows enterprise applications, allow big data solutions like Hadoop and data warehousing to exchange the data and provide this access to this data effortlessly. And this is something that we're going to be focusing in this session. We're going to be talking about this here, is about streaming platform. So we're talking about streaming platforms, a lot of things, but let's dig a little bit deeper. Let's talk about origin of the streaming platform and the streams and etc. If you think about this, simple use case where you building modern enterprises, where you collecting notification events, or like some messages from mobile apps. You need to do some processing of these events, and these events are constant, meaning that you cannot wait until these events will end. Events are flowing, and you don't know where it ends. You can put some boundaries in terms of, like, you can say, okay, so I'm only interested about events that happened within 24 hours. And after that, you can do the processing after every 24 hours. Sometimes it's not very convenient, because in this case, you're not taking into account events that come late because of physics, because of latency of networks, because of speed of light. Some of the events might be delivered after you do this cutoff. So in many places, the old paradigm where we have this like a batch style, where we're waiting until the end of the day, we do the cut, and after that we do the processing, is not working anymore. And so what you actually want to do, you don't want to have or you don't want to wait until you have all the data arrive. So what you want to have is more like a fixed windows of where you need to observe certain information, certain data. So in this case, so information will be ingested from the producers. In this case, in this particular example, it's the mobile devices through Kafka, that will provide high throughput messaging capabilities that allows these hundreds of thousand devices connect to the system and publish information to the system. Also, you can provide a continuous computation aspects using stream processing frameworks. We're going to be talking about this today a little bit. And as a result, you have some downstream applications that would be interested in the result of this processing. you have a dashboards, you have enterprise reporting systems, some other system that will be interested in this updated data. So data will arrive through this the connection, and how it can be implemented technically, we're going to be talking later in this presentation. So three pillars, three foundational elements of streaming platform is, first of all, pops up pattern. So some information, if you're interested in the data, you don't need to go and pull it. You need to subscribe to certain delivery mechanism, delivery medium. In the case of Kafka, it's going to be a topic. Now, and after that, the messages will be delivered. Messages will be delivered to you. Now, when we're talking about times where your processor is not available to process this data, and wake up after a certain time and ready to process, maybe there was a time for maintenance, some time where you're replacing some hardware, you're updating your system, things like that. Now you need to have some storage capabilities, because it would be unfortunate if your consumer of the data that are ready to consume and do something useful with this data will come and will not see the data to work with. So storage capabilities, not only providing the capabilities to publish the different information and read this information from other places, but also to store this information. And it's not enough just to pull the data back and forth. You need to have some opinionated and some framework that are already solving some of the problems for you. For example, how to implement rolling overage without just reinventing the concept of a window or windowing function, and etc. So three aspects: having this pattern of the pops up, having storage, and having ability to process. And Apache Kafka actually provides a myriad of different tools that allow you to build a streaming platform. And many tools that comes into Apache Kafka, we're going to be talking today, they are essential for building any streaming platform. So before we jump into or like zoom in the individual aspects, including this core storage, primitive, I would say, that we call the log, or we talk about the consumer and producer API, or some streaming stuff, or some connectors. Let's talk about stream processing for a little bit. So now we do have our platform that can consume this data, that can handle this data. But let's talk about some use case for a little quick. So one of the typical use cases that can illustrate streaming data is online transactions. So I was watching some of the videos. Okay, so I see. Okay, some messages start arriving to our YouTube channel. Now, I've seen many presentations when we talk about stream processing, and somehow, probably because the money is still important aspect in our lives, people talking about some business use cases, some money related use cases. So in this particular case, we're going to be talking about the credit card transactions, and specifically we're going to be talking about how to detect using stream processing tools, how to detect problems, how to detect fraudulent transactions, or the fraudulent authorization attempts. So in this case, we have a stream of some authorization attempts, stream of events, streams of facts, and from this aspect, you already can grasp that stream is a sequence of certain facts that immutable, because once this authorization attempt happened in the past, you cannot change it. It's already happened. It's already gone. So you cannot do anything. So this is very important when we're talking about about streams. So essentially, stream in this particular concept is sequence of immutable facts. Now, first stream, and the data will arrive through this channel, whatever channel. In our case, it will be Kafka, because Kafka provides us with some ordering guarantees based on partitions. We're going to be talking about this in a couple more slides, but essentially, this tool guarantees us that authorization attempts will happen, will be reflected in our system to pretty much very close to how they happen in real life. Now we need to do something with the stream to provide derived stream that contains some extra information. How we would define this possible fraud? So this is our logic that needs to be implemented. So it's not very much of Java, but still SQL in this case can be very good DSL to explaining the logic behind of this. So essentially what we're trying to do with this data is from the stream that we have authorization attempts, we need to have another stream, derived stream of the data that will have possible frauds of information, because we essentially don't need to have all transactions in that stream. We're also only interested in possible fraud. So we're creating this stream possible fraud. Now, from the source, authorization attempts is going to be our source of this. This is our logic, essentially. We're trying to say that if every 5 minutes that authorization attempt happen for particular credit card number, we need to select credit card number and number of authorization attempts. If count of this authorization attempt within 5 minutes more than 3, meaning something is fishy going on. So essentially, this is logic. This is device that will take the facts from our point of sale machine or system, will do some of the number crunching. In this case, this is logic. This is what you want to do, and provides the result as another stream that other system, downstream system, can consume and do something with it. Send notification, send mail to, or like send notification on the mobile of the credit card holder, or send physical mail to him, so he would know that there was some authorization. After that, you need to send it to downstream to do something else with it. So essentially, streaming is a tool set of dealing with events as they move. So as you can see, these different boxes like red, blue, and green boxes that goes into this device, and this device produces something new, some derived stream. In this case, it provides like a compact disk. All right. So I hope this use case was clear for everyone. Just a quick check. Are we still good on connection and the people can hear us? No side effects. Everything's fine.
Yeah, as far as I can tell, everything is great. People are watching. There are comments in the live chat on YouTube. There are something in the Slack. There are no problems as far as I know.
All right, fantastic. Thank you so much for this information. All right, so let's continue. So now we do learn that the streaming, or like a stream of data, is a sequence of fact. Now let's talk about some technology, right? How this the model from the real world actually the modeled in the actual software. And the key here, and the key of many modern systems that work with streaming data or working with some data in motion, is the concept of distributed append-only log. So the log is a special type of system or special type of software that you can use to provide some of the capabilities that very similar to some traditional systems, like maybe ActiveMQ, RabbitMQ, MQ series, and whatnot. However, distributed log or provides better scalability because it's in the name of log. So concept of scaling out system for better scalability, for better throughput, is built-in aspect that also baked in Kafka. So Kafka is distributed system based on this distributed transactional log concept. And if you think about this, the Kafka was designed, and many systems these days, many distributed systems like NoSQL systems, they were designed and used in poor startups. At the time when they were poor, they cannot afford having like a very expensive hardware. So they built in idea that you can use any type of hardware, and system needs to figure out how to tolerate all sorts of failures. So this is why the system like Kafka and the distributed transaction logging has built-in capabilities for fault tolerance. And one of the differences between a traditional messaging system is providing storage. Yes, you can say, yeah, we have this like a durable topics, or we can have a persistent topics, but it's not the same. So it's more like you trying to add something. You're trying to add something to the system that fundamentally designed to push message as far as you can push it within this like any MQ system. However, adding capability to store data is actually you're putting some additional weight to the leg of the system. So this is why in many systems that introduce this persistent queues, persistent topics, this stuff is actually crippled performance of the system. With the Kafka, the storage part was essential from the very beginning, and on the next slide, I will explain. This now. So think about this. How it works. You have append-only file. Append-only file, you writing to the end of the file. So, and all new messages will go to the end of the file. You adding. You never removing. And this is how essentially Kafka works. You can always return in any time in the past and replay events because you store these messages in here. Now, remember on the very beginning, if you joined us from the very beginning and you overcome all these technical difficulties with us, I mentioned briefly that there's some illusions about the way how the Kafka works with the way how we consume books, and there's some illusions with literature. So think about this. There's an author who wrote the book, and he published this book. And we have different capabilities of speed of reading. We have different capabilities of free time where we can read things. So essentially, we can read same book, but with different speed. So similar with concept how we're consuming data out from Kafka is consumers. Different consumers, they form a consumer group, and each consumer group can read this information, read these streams of facts in its own speed. So Fred, consumer group, reads very close to beginning of the file he starts reading from the old data. And Sally is the fastest. Sally is reading super fast. George somewhere in between. And very important fact that if Sally was reading, she's not actually removing anything from the file. So from this log, everything that stores inside this log still will be there. So, and the same with George. So George can consume. However, all these three guys, they can have their own pointers. The same way as you have this bookmark in your book, you can put a special pointers that we call offset or consumer offset, where we know that this is the message that I read the last. And there's a different semantics how you can deal with this. You can deal this every message that you read, you can send acknowledgement and say, yes, this is my consumer offset. And offset essentially defines the index where you stop. So same way as when you're reading a book, you put a bookmark in the on particular page. However, with Kafka, you're not putting actual bookmark inside your book. You have some global state where others can So for example, you want to continue to read in fault-tolerant manner, but you lost your bookmark, and your bookmark will be stored inside Kafka. Before version 0.9, these offsets they were storing on external storage. In particular, it was stored inside Zookeeper. Now everything stores in Kafka. So when you start reading, you updated your application, you updated some logic, and you want to continue reading where you left off, the Kafka will be there for you. Your offset will be stored in Kafka. So essentially, only sequential access is allowed. So if you think about how the databases work, database is a system that provides you storage, like traditional database, traditional database or NoSQL. It's pretty much like similar concept. You provide storage to store the data, and you provide the query capabilities that work with the storage. With Kafka, each and every application, it's kind of its own query system. So Kafka provides you storage with the access pattern, which is read only, and you only moving through the offset. You can scan back and forth. You can reset offsets to particular timestamp, things like that. But this is more like details. In general, distributed log is not good data structure to do querying. However, this is extremely good data structure for sequential reading. And it's extremely powerful when you have the online application that they need to have the data as it arrives. They can read this data very fast. So when I was talking about things like scalability or HA, there's usually two patterns that allow you to provide the capabilities of a scaling system. So there's two patterns basically. When you're scaling up, you beefing up this particular machine, you adding more hardware, and you increasing capacity of individual node, of individual contributor to your cluster. With modern systems, you think about the scaling out. You're adding more machines with the similar characteristics, and they provide like shared aspect or shared environment that you can use. So, and essentially, this is how the Kafka works. The distributed systems consist of multiple broker nodes that will increase capacity of your cluster when you're just adding more nodes. And let's talk about this how it works inside the Kafka. So first of all, the concept of sharding. So usually the topic inside Kafka is a data structure that consists multiple partitions. Each partition represent by this append-only file. So you have a topic. Topic might contain 10 partitions, 20 partitions, 30 partitions. It depends how you want to create it. And these partitions will be distributed across multiple broker nodes. And this is very typical how you would do with, let's start with some like a step back, like the same way how you do with concurrent hash map. You have a buckets where you based on the hash key of the particular thing, you select this bucket. Similar concept is taken into distributed systems where your buckets, your partitions, not distributed not across within one JVM, but they distributed across multiple machines. But logically, from perspective of a consumer or producer of this API, you're dealing with one system. You're dealing with one topic, and your producer always producing to one topic. So let me briefly do a quick pause and show you some of the Java code that can illustrate this idea that you have a producer, which is actually the component that you use in Java API to start writing some data into Kafka. So I use here the source code from Apache Kafka. Let me wait until my source code will switch. Can you see my screen?
Yep, and we see the Kafka Consumer Producer demo.
All right. So it is like my local copy of Apache Kafka. If you go to I use the clone from GitHub. If you go to Apache and Kafka and clone it, you'll get the source code of everything Kafka. And one of the things that there's examples folder, which is like a not so big example, but it actually illustrates very important concepts. Now, so let's start with producer concept. So if I'll go to this producer class, I do have a couple things to notice here. So first of all, we do have this a class called Kafka Producer that essentially this is the API that you're using to deal with or to publishing messages to Kafka. So in this case, you need to provide some of the properties. You need to provide the server URL. You need to provide some of the application ID. Also important thing to understand, the Kafka itself, even though it's a Java application, but Kafka doesn't store Java objects. Kafka knows how to store your binaries. So that's why before you actually storing something in Kafka, you need to serialize it. And after that, the bytes will be sent over the network. So Kafka has this very important concept that we call a zero copy that allows the server-side component read thing from the socket and stream it directly to file system, to this file, to this append-only file. And the reason for that is that we don't create a garbage in JVM. We don't create any additional objects in JVM. So in this case, we don't need to worry much about the garbage collection. There's some corner cases, obviously with Java world, we need to know how to tune garbage collection, even for Kafka, even though we use a zero copy, but there's some corner cases where you need to deal with this as well. So this is why also you need to specify how your keys and how your values will be serialized. So Kafka message contains two parts, contains key and contains value. Key is, this is the thing allows you to locate where this message will be stored. So this is why partitioning is important. We'll take a key. Based on the key, we will produce some number that will identify our our partition ID. And as you can see here, Kafka Producer provides a few APIs. You can send this asynchronously, so there's a callback that you can assign, so you get the result from the broker. For example, you will get exact allocation of this message in terms of log. You get offset, you get some timestamp, you have the partition, and all the things. So if I will take a look on this callback, I can also on completion I can get a record metadata, and inside this record metadata we can add all sorts of things. For example, we would know in what partition what was the offset of this particular message that consumer will use in the future, and so on. Or if you don't care about this, you can use like emulated synchronous call. So in this particular case, this is how you do it. You do the producer record. This is your key. This is your value, and after that, you will wait until the producer will end. So this is the producer side. So this is the broker is a separate process, and how to start broker, how to deal with broker. So one of the things that you can do actually, and let me switch to another window, is to start a Kafka. So there's some lots of there's a scripts that allow you to start the Kafka server, allow you to stop the Kafka server. However, you also will require some additional system to run. For example, Kafka uses Zookeeper because inside Zookeeper we'll store some additional metadata. So Zookeeper needs to start before we start Kafka. So you need to, after that, you need to go something like the Zookeeper, start server, server start. Similar way how we can do for Kafka. So if you want to develop this locally, so you need to have Zookeeper, you need to have Kafka. It's all part of installation when you download from Apache Kafka. But today I want to show you, I think, in my opinion, much better way. So if I want to use the Kafka for my local development, if I want to use this like a producer consumer thing, I will use this utility called the Confluent. So it's command line tool that allow me to start different components. And interesting enough that this tool actually knows that, for example, if I want to say, I have this like a small alias for this, so I don't need to type the Confluent at the time. And status of Kafka, for example. So in this case, he knows that Zookeeper is down and Kafka is down. So if I want to start this, I can say start Kafka and don't think anything else. So in this case, this small CLI utility knows how to get Zookeeper started, knows how to get Kafka started. So it's all up and running. So if I will do list of topics that I have no topics right now there because right now I just started new. So if I want to create some topic, I will use this command Kafka topics, and I'll create a topic that will contain 5 partitions, replication factor 1, because I started just one node, so I don't have any like replication factor. We're going to be talking about replication in the next slide, but bear with me. Now, so if I will do this, it will create a topic. And if I will do a list of topics, I will see some additional topics. So there's some internal topics that will collect some information about the metrics. So in this case, __ topics. Typically, it's the topics that will be used internally by tools that collect metrics. But we see our topic VJug. Now, now I have my Kafka up and running, so I essentially can use this application to start it, just to demonstrate that it's actually, hopefully it will not blow up. So what essentially this application will do, producer will produce some data and consumer will consume some data, but it's not the very relevant for, or very important in terms of what it does, just to show you how it actually, works. So the producer will write the message, and also it writes a message to partition 0, and it also plays the message with particular offset, and our consumer will receive message for particular offset. So nothing really very exciting here because it's very low-level API. I will show you some of the other aspects that you can do. But if you do things like list of topics, the topic 1 was created implicitly because I don't need to create the topic. If topic was not there and there's configuration that says topic creation, auto creation is allowed, so you can do this without any like creating topic upfront. But it will use some defaults, and sometimes you don't need defaults and things like that. Now you can say, okay, Viktor, so what about like if I don't wanna like do anything from Java, can I use any like a console tools? So yeah, so we do have so there's a Kafka producer. So there is a tool called Kafka Console Producer that will get a list of brokers and the topic where I need to produce, and I can start typing some things. Hello. I'll do hello 1, hello 2, etc. And on the other side, let me start the consumer that will start reading this thing. So that's a very important thing to show you. I will show you two very things. So first of all, I'll start the consumer, and the consumer right now will not display anything because there's no data. But if I will start typing here, lot 3, I'll start receiving data on the other side, as you can see here. This is a very important concept because right now my console consumer started with so-called the consumer offset reset policy, which equals earliest, which means that because I just started and I'm just start reading from the end of this file. So and I'm not reading from the beginning because I'm not interested in the beginning. But if I am interesting from beginning, I can restart this consumer with a key from the beginning. So in this case, it will replay all messages from beginning. And after that, it also will write hello, etc. Now, Also, because I talk a little bit about replication and the fault tolerance and all these important things in a modern distributed system, is that replication is built in. So if you start Kafka in distributed mode, meaning that you start more than one instance of Kafka Broker, they will form a cluster. And after that, Zookeeper will be used as a provider, will be providing ability to decide which partition is a leader. Because Kafka has this, I'm just going a little bit deeper here, but you guys deserve this. This is a very cool topic about consistency in distributed systems, and different systems provide different consistency guarantees, the way how the data will be seen by other members. And in Kafka, because Kafka uses this distributed transactional log, append only log as a foundational brick that you use to build this foundation. The fundamental piece of consistency guarantees here is that you always writing to leader information will be provided to you when you connect, and this metadata will be sent to you, and you will know that this particular partition will be leader, and you always consuming from leader. So in this case, there will be no eventual consistency in terms of, okay, so I will wait until this replica will replicate, and after that, eventually I will see right value. So consumer always will be the producer will be always producing here, and consumer will always be consuming from the same thing. So I see some question in the YouTube channel, so I will address this over here. So some people saying that, oh, I see some of the messages are not in the order how we put it here. And the reason for that is that because we guaranteed, Kafka guarantees order only within partitions. So what does it mean? It means that when the producer writes something into Kafka Broker, we take the key, and based on the key, we figure out a particular partition. If we push messages for the same key, these messages will end up in the same partition. In this case, these messages will be consumed in the same order how they were produced. So what we see here is when we created topic VJug, we set 5 partitions. So in this case, we're not providing any keys, we're just publishing values. In this case, key will be null, and when you're creating pushing messages with null key, this message will be the partition will be chosen on the round robin fashion. So this is why all these messages, they will not be on the same partition. So I can show you if I can do something like this. You can say, Viktor, how I can get the order if I want to have order? Sometimes when you're dealing with some legacy systems, you want to have a global order. But global order is just one of the case of partitioning where your topic has just one partition. So if I will do something like this, create new topic, let's call it VJug2, and partition count equals 1. So in this case, I created this topic VJug1, VJug2, and now I will do a producer to VJug2, and I will do hello, 1, hello, 2, hello, 3. And if I will start consuming from the beginning, from the topic VJug2, I will get this exact the same order. So this is very important and a very good catch. Thanks for the people who's watching us in the live broadcast on YouTube. Thanks for this question. This explains a lot of concepts. And also, as you can see here, because the partitions, there will be more than one partition, we're not publishing any metadata. We're just publishing some value that we consume this. But if you look in some of the metadata, you will see these different messages, they came from different partitions. So this is why you will not have this kind of order. But thanks for this question. Now, so also, like, this is how it looks like from perspective of replication. If you want to have more, more fault-tolerant system, right? So you can have multiple broker nodes, you can have different replication factor, and in case of some of the things will go south, So for example, one of the nodes will go down, some of the replica will disappear, some of other replicas, like the leader will disappear, but other replica has the same data and will take over as a leader afterwards. Now, so consumers also remember this story when I was talking about you reading a book and your friend reading a book. So you're reading the same book, but he has more free time to read this book, so he
Victor,
can do. Yes.
Can I stop you for a second? We get the reports that the video is unavailable. We're still live. We're still on air. So I need just to figure out.
Video is not available. I see also spinning wheel in YouTube. Let me see.
Can you try refreshing the YouTube page? Because I see that we're still live on air, so the problem should not be on our Hangouts end, and it could be just YouTube, but it is struggling indeed.
I guess it's just a quite popular session, and we just bring in
Hangouts
to its knees.
Certainly, it's extremely popular. Let's do this. Let's continue with the session because I think it still records everything, and then the video on YouTube will just catch up.
I think a video on YouTube just catched up because I see some consumer slides right now. So guys, let me know if video continued. Video stopped. Okay, so give it one more.
I think it's good. I think it caught up with our current timestamp, and I see the reports that we are back now.
Yeah. So as you can see, it's a good illustration of what I was just trying to say. Like different consumers of this video stream, they can consume this video in their own pace. So essentially, many producer can produce to the same topic, many consumers can read from the same topics. Or like if you want to have one producer, like one writer of the book that will write this book, and you have multiple readers. And also the Kafka is designed to be linearly scaled, so number of consumers should not affect one consumer should not be affecting other. Now, interesting aspect here also is that they also have different consumer groups. You can scale different consumer groups differently. So for example, like with example from your friend who has more free time, so he can consume more data, but you have limited number of time, so you need to, you will still catch up to the same information, but not at the time. Now, a little bit about global and the replication. So you can also use the same concept, but at scale. Internally, replication can be turned through global replication. They replicate multiple data centers, etc. So I will skip that for now. Now, there was very interesting questions in YouTube chat that like how I can stream data to database or from database. So when I was talking about on the very beginning, Kafka itself, let me actually quickly show you my screen. So since I have this source code tree here, there's very many interesting aspects. So it's not only Kafka core, but also there is the concept of Connect. So it's another sub project that has some interesting aspects. I was talking about Connect in just a moment. Also, it has a concept of streams, which is the Kafka streams, which is another framework that I will demonstrate in a couple more slides. Now, so Connect and the connectors is the way how you can define off-the-shelf components that allow you to bring data in and data out. So, for example, Kafka Connect is the separate process that runs separately from Kafka Broker that listens changes from your database and pushes these changes to your Kafka Broker. Once you're done with your processing, so for example, if we return to my use case of data that authorization attempt flow into the system. Also, you want to say this the fraudulent attempts for further audit. You can have a consumer that writes this in database, or you can have a connector that can simply listen this particular topic and populate data to to database. So Connect is actually a pretty cool framework, and there's plenty of connectors available right now. You can read right to different databases, different systems, even cloud, Amazon 3, some the MongoDB, etc., etc., etc. So Connect is actually very cool piece of technology where you don't need to reinvent the wheel, and you don't need to think about this how you will scale reads from your database if you need to stream your changes from database into Kafka. Now, let me talk a little bit about this streaming engine. So this is the third aspect. So we talk about the PubSub concept, which is producer and consumer. I didn't show you much of the code of the consumer, but let me do this right now. So the consumer itself also needs to know where to connect the Kafka server. Also, you need to define, this is very important parameter, you need to define a consumer group that will form a, basically it's your application. And if two applications start with the same consumer group, they will join one consumer group. In this case, you can scale your reads. Interesting aspect here. You do subscribe, and after that, you do, so where is this? Do work exactly? The consumer is pulling data constantly, and so we have here. So this is some example how you can run this as a separate thread. But essentially, what it will do, as you can see, I'm a little bit rusty on my Scala, but this is Scala that Kafka has some of the Scala capabilities. So this is method that you need to implement in your Java. And as you can see here, you run this do work in a while loop forever. And this is also a very important aspect. So Kafka consumers, they're not expecting data will be pushed to them. So Kafka consumers always pulling data when they're ready. Same way as that, when you're ready to read new book of your favorite author, you will just, read this in your time, not when the author will just dump it to you. So this is why it's another also a different thing from the traditional messaging system where you're expecting push, you're expecting the system will push you. So in this case, having these pool capabilities is more allows you to be more resilient, and you not overwhelm your consumer with high load of this. Your producer can be faster. So in the Kafka will be natural buffer for this burst of messages. Now, so this is about consumer. We talk a little bit briefly about connectors. And so streaming engine. So now stream processing. So it's good that we can consume some messages, we can do some things, but it's very nice if the API will provide us something like this, right? So we don't need to think a lot about how we will, write this window function. Like how many of you wrote this windowing functions yourself? Probably you did. If you ever dealing with some messaging system, you need to do some running overage type of thing. You need to store somewhere intermediate results and some maybe database or some in memory cache and something like that. So what about the framework that will provide you these capabilities? The framework provides you with opinionated way how you're dealing with this. So this is exactly what Kafka streams. And the Kafka streams is also will be very familiar for many Java developers, because in Java 8 there was introduction of Java util streams API, where you can build your pipelines of data processing. So the Kafka streams also brings this concept to developers. As you can see here, the stream in this case, we will take the stream from Kafka and we'll do something. So in this particular case, we do some cool transformation from streams of caterpillars to stream of butterflies. So here we go, another Franz Kafka reference where we have a metamorphosis of caterpillars to butterflies, but not how it was in the book when the person was transformed. and to inspect things like that. So just real quick, there's different types of topics inside the Kafka. So one topic that can have history of these facts, history of everything. So it's a regular topic. However, there's another type of topics that can be compacted, meaning that this topic will contain only latest value for particular key, which is also very, very cool. Sometimes you don't need to have full history. You just need to have a latest state of your system. So you're populating your some in inventories website. So you don't interesting prices within last day. You're interested in what's the current price for particular inventory. So in this case, you can store it in a compacted topic. In compaction, but do not be confused with compression, because it's two different things in the Kafka world. In the compaction, you actually will not have a full-blown history of this item. You will have latest and greatest value for particular key. And the Kafka streams takes this concept. There's concept of stream that it's going to be Java abstraction on top of the Kafka topic, and the table that will be Java abstraction on top of compacted topic. So here's another example where you will apply some of the the windowing functions in a situation where you have late events. But let's face it, it's a asynchronous world. There's a real world. There's some delays that happen. That some events might arrive out of order, out of time. So in this case, you need to also will be dealing with this, and you also can send email only every 5 minutes. So in this case, your payment service and the order service sends messages into Kafka, and after that you do join. And how it can be done with the Kafka streams, we have orders, stream of orders, stream of payments, and we can do join based on the key, where our key will be the order ID, and after that we will send email when both arrived. So we waited for one order to arrive, and after that, when the payment arrived, we can send email that all good. We'll do joining by key. Interesting thing that you also can have enriched stream. So where you have a stream of data that comes into your system as events. Also, you can have something that's stored inside the Kafka that will be enriching this information. For example, if you want to provide a email, some rich email that will have certain elements of your account ID, you need to also do join. So, and this is how it can be done with the Kafka Streams API, is that you have orders, information about payments, and information about customers. So the table about customers will take this information by customer ID and will enrich the order information with customer information ID. And when the payment will come, we'll send the mail. Now you have it. So this is like complete platform. Obviously, it was not possible to explain everything, to cover every aspect of API. I tried to give you just a brief introduction to certain concepts. So you have a pub subsystem that you can use, the producer and consumer. There's a connector framework that allow you to build a reusable components that can be write data into Kafka or from Kafka, and there's stream engine that allows you to do complex things like a joining of streams, or providing the ways how you can design stateful stream processing application that will have windows, that will have these windows can be rolling, they be tumbling, etc., etc. So how you can learn more? So first of all, I would encourage you to go and see if there's some meetup around you in your town. Most likely there would be some meetup close to you, so you can come and talk to other people, share some knowledge. Everything that I described also can be found somewhere online. What also very important thing is that there's some free books bundles that were written by Confluent employees. some of the books are around the concept of distributed transactional log, some around around concept of streaming. Another book, Kafka Definitive Guide, is basically, I would say, in my humble opinion, there's only one book about Kafka that you ever need. It's amazing book written by amazing people, and it has all sorts of depth that you're looking for. Plus, there's new addition to these books. If you Kafka becoming more important, the component of the systems, where Kafka not only uses as a like ingestion layer for like Hadoop or from other like distributed processing systems, but also becoming a backbone for event-driven systems, microservices, etc. So this book, Designing Event-Driven Microservices Systems, allows you to understand how to build those. Also, if you have not enough Slacks in your Slack application, welcome to our community. We do have a Slack, and you can see this like a short link to our Slack. You can join. We have all sorts of community is huge, and you can ask any type of questions that you have. And another important thing that we also running the community conference that's called the Kafka Summit. Kafka Summit is the event where we trying to bring speakers from community and organizations who build and use stream processing systems. So this is how you can talk to some of the thought leaders in streaming community and join us here to Kafka Summit. So next Kafka Summit is going to be in October 16th and 17th. You can get 20% off if you want to buy the ticket from this promo code Gamov 20. I've seen some questions like how I can get this awesome the tool that like Confluent CLI, for example. So we do have this Confluent platform, which is essentially Apache Kafka plus some other components, including REST proxy, including schema registry, and some other clients. And this is a part of Confluent open source. You can grab this, the CLI, and start doing development today. And before I go, I have one more last thing to say. So I was talking to one of the customers. So since I work as a solutions architect, and I'm talking a lot with customers, I'm helping with installation, with setup. I help with all sorts of tuning questions. Remember, if you very strong person in doing all these things with hiring. And so yeah, I was talking to them, and they were running. It's like big organization, big bank, and they were running their internal conference. And one of the team, they have a huge success of dealing with uploading like a big amount of data from the mainframe systems, where just historically place where data went for good. And when was in mainframe, was not super easy to get other to get it to use in other systems. So they were talking about their use case and how they build a connector that allowed them to offload the data inside the Kafka, and how they can bring more and more new consumers to the system, so the people can use this data, because on the mainframe they did like a lot of processing and things like that. So, and he was doing like this internal presentation for other developers, for other management, and he needs to do some of the selling points, right? So he needs to not convince, but at least share their experience and show the things how these things work out for them. And one of the things that his colleagues saying to him, "Hey, Mike, when you're going to be talking about this, try to not oversold." Okay, so we had a huge success with this, and when you'll be talking to other people, just keep it humble. So he started this presentation with this slide. So I just took it from him, and he said like there were three things in the history of humankind that essentially changed a lot of things and moved the progress drastically. So first one is invention of fire. Second one is invention of wheel. And the third one is invention of Apache Kafka. So Apache Kafka brings a new major paradigm shift in the way how we're thinking about data, how we're dealing with data. And I want to say thank you for being with us today, for spending this hour and a half with us. As usual, if you have any questions, please don't hesitate to contact me on Twitter. Don't hesitate to contact me on email. If you looking for the awesome place to work, we do have some opening position. Just check this website. Thank you for your time, Oleg. Thank you for this awesome opportunity to speak. I think so, I'm kind of don't want to jump in front of gun, but essentially I see few opportunities for follow-up talks and dive into maybe Kafka streams and something like that.
Absolutely.
But, yeah.
Absolutely. Thank you, Viktor. That was a great session. And it was more educational than I initially thought it would be, because I've seen a couple of Kafka talks before myself and I learned things here. So thank you so much. I hope everybody has overcome the technical difficulties, unfortunately, which we experienced during this session, but we managed to get over that. If you have a little bit of time more, I would love to ask you a couple of questions which I accumulated during the presentation.
Yeah, absolutely. This is whole point is not only me giving you some information, but also me consuming some of the information from the community and some questions that might be.
So if you like, if you are still with us and you're still in the live chat, live session channel on the Slack, and if you have more questions, please ask them. We have a couple of minutes. But so somewhere in the very beginning of the session, Raj asks, is it a good idea to have persistent topics, in your opinion?
So I would have some follow-up questions, and if we're talking about persistent topics in Kafka, or we're talking about persistent topics in
well, I assume in Kafka, because
so in Kafka the topics are persistent by default. So everything that you write to Kafka, I briefly mentioned this, but when the payload comes to the socket, this binary payload will be directly streamed to place that called page cache, which is the place that it's kind of like operating system buffer. And the page cache will accumulate some of the data, and after that, it will be flushed into actual file. So in this case, the couple benefits that this is how the Kafka works. Like essentially, this is a fundamental aspect of Kafka, that you're not creating garbage. You're not creating some intermediate objects. So in this case, it's getting really fast, and data will be persisted in case of failures. So sometimes Kafka is characterized as a messaging system with database durability guarantees. It's very fair, but it really depends. I like this. Again, this is from the Ben Stoffer's book about the designing event-driven systems, and he has this like a metaphor that when it depends who you're talking, when the few blind people approach the elephant from the different the parts of this elephant, and they touch different the parts of the elephant, and they thought that they were touching something themselves. So if you're coming from the messaging world, you will find a lot of aspects that sound familiar. For example, PubSub aspect. If you're coming from database world or distributed database world, you will find multiple similarities. For example, the way how the consistent hashing works in terms of how the data will be sharded, and replication and things like that. If you're coming from the like data replication world, pretty much how your underlying systems, database systems work, they actually use the concept of transactional log, And every time when your database crashes, you're restarting this, you might see this message that we're restoring state of database from transaction log. It has the equivalence of the Kafka. So answer is it's good idea, since it's a fundamental aspect of Kafka, and also it is actually works very well in many use cases these days. So Kafka used in many organizations all over the world in the different use cases.
Excellent. So I hope that answers the question. I know that Raj posted the follow-up something in the chat. So if you take a look at that later, you can probably elaborate a bit more on his particular concern.
And don't hesitate to reach out in Twitter or in the Slack community. Yeah.
So a quick question: is it possible to use Kafka? Stefan asks this. Is it possible to use Kafka as a distributed lock?
So I think when we're talking about distributed lock, we talking about controlling of some of the jobs, accessing some of the shared resources, right? I would say in this case, it's much better to use some. Again, this design will require some of the elaboration. We can talk about things, but in general, I would recommend every time where you need to have kind of like a key value access, but I not assume because I have some of the background in distributed locking as well. I used to work in Hazelcast before. So having this log by particular key, you need to have like a constant time to respond. With Kafka, it's not key value storage. So you need to have materialized representation of this data somewhere. You can use the Kafka to transfer it. You can design and develop a locking system based on that. However, when you need to have the access to this data by key value, you need to use some other technologies. Kafka Streams, for example, provides this ability that's called interactive queries that essentially allows you to materialize some of the data that you store in Kafka topic within this Java application and provide the access, like a key value access. So technically, it's possible to design this system with all sorts of tools. However, it will require some additional elaboration in terms of design, what's the requirements and things like that. There are ready-to-use like tools that designed to solve this purpose. So my answer is, technically you can design this, but it will require some additional elaboration.
Excellent. Thank you so much. A quick question, which might have been answered in chat already. Jay Milkiewicz asks that they thought that in Kafka, offsets are stored on the clients and not in the Kafka broker itself. Is it true, or?
So Kafka offsets, it's the pointers of, just a quick refresher. So Kafka offsets is the pointers where the data, where the particular consumer stopped, or where the particular message was written. So information about offsets, you can store it wherever you want. It's actually metadata that you can read from Kafka. You can store this information about offsets. When you do publish, remember, when you do this producer.send, I showed you that you can use record metadata that will define the offset of this particular record in this log. So once this data is written, so this is never going to change. And you can save this information everywhere. So by default, the information about offsets, consumer offsets, will be stored inside the Kafka in special topic _ consumer offset topic. Before that, this information was stored in Zookeeper. There are some use cases where people can store it outside. Some people can store it's on I don't know, like in S3, for example. So in this case, they have a durability. In case of consumer offset topic will be expired, because consumer offset topics is also another topic. So some of the data I haven't talked about this, but some information inside the topic can be expired. You can define a retention policy, so it can be automatically collected. So the answer is here, by default, everything's stored inside the Kafka. Kafka doesn't require any additional third-party storage. Whatever you need to use with Kafka, Kafka will provide this for you. But what I like to say to people, Kafka, a good thing about Kafka is that there's a lot of things to, lots of knobs, lots of APIs. The bad thing about Kafka, there's lots of APIs and knobs. So essentially, you can do this if you, for some reason, need to store the offset outside of Kafka.
Okay, excellent. And now we have two more rather large questions. So if you could answer them kind of like maybe in short or forward to resource and then elaborate maybe later, because I'm not sure how much time this will take. So Loss asks, my understanding is that Kafka is a pub sub based, right? What is a good way to have a number of consumers read data, like the incoming messages, without duplicating work? What I understand is that if you have a log of messages, how do you kind of have multiple consumers not consume the same messages again and again, right?
The short answer is use Kafka streams. And I will elaborate about this, like without going into again much of discussion. And there's actually a huge topic around exactly once processing and not introducing duplicates. A lot of work was done by Kafka community and some engineers here at Confluent to make this happen at the product itself. So the simplest way is to use Kafka streams for your framework to process this, because in Kafka streams there is just a one configuration that says like use exactly once. In this case, the framework itself will take care of this responsibility.
And like every message will be processed by like a single consumer.
Yeah.
Oh, awesome! I thought the answer would be longer, to be honest.
Yeah, no, there's longer version of this answer, and it will also be involving a whiteboarding and explaining how the consumer group works, and explaining what is the consumer group rebalance, explaining about how the rebalance protocol works and how it will be reflected in the different APIs, like a consumer API, or how it will be reflected in Kafka streams. So I would say again, if community will find this interesting, I maybe return with some follow-up session to talk about more advanced topics. If
yeah, that'd be lovely. I have another question, and I strongly suspect that the answer to this would be very similar. Raj asks again, consider I have the messages being produced from some IoT devices, and the messages may be duplicated sometimes as IoT devices, network, and so on. Can we filter out the duplicates at consumer side using only Kafka and not taking help of any other storage like Redis Memcache or other SQL, non-SQL solutions?
Short answer is yes. You can use the KSQL, which is a framework that allows you to write structural queries on top of Kafka, and the filtering of incoming data is the bread and butter of KSQL. So you're just writing this new create stream from IoT data and after that, like you can put this device ID equals what, and you can filter out all duplicates using a certain criteria. Obviously, you have criteria, and another option is to use Kafka streams for that. So the KSQL is also built on top of Kafka streams. So KSQL is designed to be used for people without any like a Java background. It's just another process that runs side by side, and result of this can be stored in Kafka and can be used by other downstream systems without even knowing that this is something that coming from preprocessor. So short answer is yes, and many batteries, like many frameworks coming without batteries included. Kafka comes with a lot of batteries included.
Excellent. And maybe perhaps the last one, we'll see how it goes. So Tomasz Biruta asks, imagine you have a consumer can read messages from a topic from the beginning. But now if you have the setup where the data is in an external store, which connects to Kafka via a connector, and can you then like read the messages from the beginning, including everything that was in a database, right?
So
let me elaborate because there were confusion. So let's say you have a database and use a connector for Kafka, right? And it pulls the data to Kafka. And now you deploy a new service and would like to reprocess all the data from the database.
So you can always reset the offset and to the particular point. If you know timestamp, you can reset offset to particular timestamp of message. So there is only flexibility, and there's like a lot of things can be done without going again much of the details. I don't obviously I don't know use case, and some of the things can be achieved differently, but I don't see why not. So
okay,
yeah,
very cool. Oh, and the last question. Sankar Valuri asks, do you stream and I assume Kafka streams, is the output of that computation, does it go to a topic? Or
yes. In your API stream, you can do two. In this case, method name to and in this case, it just goes to topic. So idea of Kafka streams is that it's going to be like a embeddable framework, embeddable library. I probably need to do another session about Kafka streams only, because there's a lot of things. There's a lot of interesting things that you can do with Kafka streams. So yeah, I actually will be doing this session in the Kafka Summit about Kafka streams. So I think it's maybe after summit I can come and present here. So in this case, people will have good idea. But there are plenty of videos from the Kafka Summit previous years where you can learn some other questions. So hit me up on Twitter. I will send you some of the videos.
excellent.
From Kafka Summit 2017, for example.
Excellent suggestion. Thank you once again for the time, and thank you for answering all the questions. I don't think we have any questions. We have a request for the follow-up session in the chat, collecting thumbs ups. So if that thumbs up number will reach a certain threshold, we'll consider scheduling it much sooner than normally we would. No, absolutely. It was a blast to be present here, and it was a blast to learn with you. Thank you so much. If you are still with us and watching us, follow Viktor on Twitter. If you have any more questions, he is perhaps the best resource to learn about Kafka and the data stream platform and all the ecosystem around that. So
thank you very much. Thank you very much for your time. You guys awesome. Thanks for staying with us a little bit over time that we planned, but it was pretty cool. Share all your questions in Twitter. Put this hashtag Kafka streams. Put hashtags Apache Kafka. In this case, we have a huge community of people who look into this one, and we're working with community and providing feedback to people who are using this. And again, do not forget we have a Slack also. And in the Slack, we also have a lot of people who look into this one.
I just remembered, there was a question about Confluent and work. So just like drop in the live session Slack on the VJAC. I'll point you to that point in our read only, append only log of messages.
Exactly.
Anyway, thanks again. Thank you so much for watching us. Until the next time, bye.
Thank you.